In this video, I am going to discuss the definition of random variable and the conditions for a function to be a random variable. Let's start with the definition. A random variable may be defined as rule of functional relationship that assigns real numbers to each possible outcome of a random experiment. Or the other definition is a random variable is a function that assigns a real number to each sample point in the sample space of a random experiment. Random variable is represented by uppercase letter x and the values of the random variables are represented by lowercase letter x. Example of random variable. Let us take a random experiment, that is tossing two coins at a time. When we toss two coins at a time, the number of possible outcomes, that is sample space S equals to head, 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 tail, tail, head, tail, tail. Let us take the random variable as number of heads. From the sample space, the random variable x equals to 2 heads, 1 head and no heads. That is x equals to 0. That is no head occurs when we toss two coins at a time, and x equals to 1. That means one head occurs when we toss two coins at a time. X equals to 2. That corresponds to 2 head occurs when we toss two coins at a time. X equals to 0, 1, 2. I am writing these values in the tabular form. This is random variable and this is the probability value of the random variable. For the 0, the probability value is 1 by 4. And for 1, the probability value is 2 by 4 is equals to 1 by 2. And for 2, it is 1 by 4. Now, I am going to discuss the conditions for a function to be a random variable. There are few conditions for a function to be a random variable. The first condition is the random variable must not be multi-valued. That is, every point in the sample space must correspond to only one real value. Sample space S equals to head, 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 tail, tail, head, tail, tail. The random variable is 2, 1, 1, 0. And the second condition is the set x is less than or equals to small x should be an event for any real number small x. That is probability of x less than or equals to small x. Suppose probability of x less than or equals to 1 equals to probability of x equals to 0 plus probability of x equals to 1. We know that probability of x equals to 0 is 1 by 4 and probability of x equals to 1 is 2 by 4. So the overall probability of x less than or equals to 1 is 3 by 4. And the final condition is the probabilities of the events x equals to infinite and x equals to minus infinite is equals to 0. That is probability of x equals to infinite equals to probability of x equals to minus infinite equals to 0, because for infinite and negative values we cannot assign the values. Thank you.